All right, so now what do we do with integrals over sums? Well, it's the same as before. We had derivatives. You would just take the derivative of each term. So we do the same thing. We take the integral of each term. So this would become, and we're going to add 1 to each. This would be x to the 4th. And then we put a 4. There's no coefficient in front other than 1, so we put a 1. And then we do it again. So this would be minus, and then we have x to the 2. And then we put a 2. And then we bring down that 3. And then remember, constants, we have to put an x on front of them. And then we always just go back and we check everything. So the 4 would cancel and we get 3. The 2 would cancel and we get 3x. And then this is just has a coefficient, so we put 2. And then plus c. And there you have it. There is our antiderivative. All right, what about this one? So same thing, plus 1, plus 1, plus 1. So this would be y to the 4th over 4, and then we bring down the negative 4. Minus y cubed over 3, and bring down the 7. And then y squared over 2, bring down the 5. And then again, the constant is just an x plus c, and then we check. So this is going to give us negative 1. We should probably simplify it first. So negative y to the 4th minus 7/3 y cubed plus 5/2 y squared minus 9, and that is a y, not an x. Y and plus c. See, the letter that we use is the letter that we have to use. So if it says dx, it's with respect to x, we put an x. If it's dy, it's respect to y, we put a y. You don't have to worry. They're going to give you the same letter, and they will match. So don't worry about that. Okay. So now we check it. So it would be 4, subtract 1 is 3. The 3 cancels, and we subtract 1, it's 2. Perfect. The 2 cancels, subtract 1, it's 1. And then this is just plain old minus 9. Perfect. And the constant would be 0. So let's try another one. Now I've added a 3 here because the previous form that's on the lecture notes is not going to work for what we're looking for. Now these have to be put in that power form. We need that general power form, just like derivatives. So you always want to bring those denominators up. And so now we have this. So we're going to take and add 1 to each denominator. And so this would become negative 1. And then again, we put negative 1 here, and then that coefficient of 1. Minus. Now adding 1, just like before, we would take the bottom and subtract it to find the derivative. So the opposite now is we add it. So what I like to do is, instead of putting plus 1 here, this 1 is really 2 over 2 that we're adding. So really all you're going to do is take the denominator and add it to the numerator. So what is 2 right here? 2 plus negative 1. That would be positive 1/2. So 2 plus 1 minus 1 is 1/2. And then when you rewrite it, it's going to look like this. But if you remember, if you divide by 1/2, all it is the reciprocal. So whatever fractional exponent you get, just flip it. And then we move on. Plus, so this would be f to the negative 2. And so then I put a negative 2 here and bring down the 3. Now we rewrite. Oops, this is a fractional exponent, a negative exponent, so we have to make sure that it is a denominator. Minus 2, and that is a square root of f, minus 3 over 2f squared. And again, always in green, so you don't forget it, plus c. Now we just have to check it. So this would have been the negative 1 comes down and cancels, and we subtract 1, which is negative 2. The 1/2 would come down and cancel, and then we subtract 1, and it's negative 1/2. The negative 2 would come down, cancel, and then we would get negative 3, and we're left with 3, so it checks perfectly. So this is what you do with these problems. Thank you.